All right. Thanks everybody for joining. So I'm back with my esteemed colleague, Mr. Peter Cutler.
Morning. Morning.
Mr. Cutler, how are you?
I'm doing okay today. How are you, Mark?
Not bad, thank you. Not bad at all. So, all right. So again, thanks everybody for joining us. So what we're doing a number of different 30-minute fireside chat style webinars talking about different deployment models to give people a better sense of how this stuff works, how flexible we can be, and some of the considerations, particularly technical considerations for how to deploy in these different architectures. So today's title, as you see, is optimizing edge and scrubbing deployments, which technically are two different architectures, but we're gonna put them in together. So what we'll do is, again, give some consideration. This is meant to be a more technical conversation, not a salesy kind of thing. Of course, I'm going to pitch us a little bit. I mean, it's what I do. But so let's just jump right in. So, all right, we're going to talk edge defense first.
Okay.
So, actually, would you please just give a quick definition of what that is to set the scope, and then and I know you're just saying beforehand there are complete conferences on this topic, so we're going to hit it quickly. We're not going to go that deep. But what are some of the capabilities that exist today within edge devices, when we're really talking routers here, to filter and redirect DDoS traffic? So one quick definition of what we're talking about, and two, just some of the capabilities.
Okay, sure. So, edge defense. Well, I guess, edge to me, in the context of networks, means, some sort of demarcation point between one network and another. Or perhaps if you're running various different zones in a network, such as core internet service provider edge, border network gateway edge, radio access network edge, it's really the point at which the traffic is about to be transferred into a different part of the network, either for a different purpose, but more commonly, that interaction between the internet, so a network of other networks, and the network that we operate here. So edge defense is characterized really by the aggregation of link capacity, which seems to congregate at these areas of the edge, because these links come together and they converge into a place where suddenly you have lots of capacity converging together, and hopefully we can do something about it. So that really is what edge defense is about.
Okay, perfect. And then again, so that capabilities we're going to talk about is just filtering out the bad stuff, how to redirect it, and so on. When you get into that, though, I mean, what are some limitations as we're talking about this that we should keep in mind?
Sure. Well, like you say, Mark, there are whole conferences on this topic around what can be done, both from just to be a good citizen on the internet, if you're a network operator, in terms of what should be done, in terms of sanitizing and filtering out traffic that we know will make its way towards our networks. There are best current practices on those, BCP 38, BCP 84, and each one will be relevant for how and the type and shape of network that you're operating. So I won't specifically go into too much of those, but we can maybe touch on that subject another time. Okay. The general consensus amongst the people and teams that I work with is that they often have some sort of broad-based filtering capability, whether that's for making sure that the sources are not fraudulently sending from sources that aren't real, so often referred to as spoofing, so that the traffic that enters our network is from legitimate source IPs out there on the internet, v4, v6. There are access control layer filters that we can put on the interfaces that face the edge of our network. Sometimes if you're in a Cisco world, that's an ACL. If you live in a different land, like a Nokia or a Juniper, or any other vendors are available, right? There'll be filter policies, or there'll be firewall filters, and we can place those on, and we can do things like filtering out static source ports, or we can put some basic policers on there for certain types of traffic.
Can I ask for a point of clarification, because there's an add-on question I wanted to add here.
Sure.
So when you're saying are you talking about Corero, or are we talking about just generally like we as network engineers can do X, Y, or Z?
I think I'm talking about the collective we. If you're interested in operating a network, that's generally what people do.
Okay.
Yeah, thanks for clarifying.
Yeah, because that goes into my next question, because I think this will help frame it up. So when the Corero are integrating, or how are we Corero handling DDoS protection when it comes to
Mm.
edge protection? So can you talk a little bit, because that's going to frame how we talk about everything else. So what is that integration point? What does it
Okay.
get a
Yeah.
customer to have this kind of
Yeah,
integration?
absolutely. Well, what essentially what Team Carrero's been doing and pushing the fringes of in the last couple of years, and what they're at the forefront of is looking at the silicon that exists in those edge devices, and that ranges wildly from vendor to vendor, and looking at the capability of that silicon with respect to its ability to filter. Because that's a key characteristic of
Hmm.
the task of DDoS defense. Looking at the accuracy of the filtering in each case, and looking at the speed and scale that can be achieved from different device to different device. And I'm talking now both from whether we're using a router, router, switch, or any other device, or vendor to vendor. So what we've done, or what Team Corero has done, is figured out a way of using intelligent software to orchestrate very detailed filters that can be applied at the edge of our networks for the purpose of DDoS defense. That's in a nutshell.
Okay. And if you don't mind too, I might be skipping ahead, but I want to focus on this because we're going to talk about scrubbing, and I'm actually rearranging our agenda, if you don't
Okay.
mind, in my head a little bit. But when it comes down to edge protection, now me coming from Cisco, you'd never convince me that there are other manufacturers, but apparently there are. Now
Yeah.
that I'm out of Cisco, but no, but I mean, where I'm going with this is how, when it comes to that edge protection, what is the mechanism that we're able to work with all these different vendors? Is there any kind of specialization that we're looking at? Is it all standards based? Would you mind digging into that a little bit?
It is standards based. I think it has to be when you're running a multi-vendor network. Certainly from a networking perspective, the standards really are about what protocol are my devices able to communicate with me on, and there's a couple of characteristics that it will determine how we communicate with those devices. The first one is speed. The second one is risk, and those determine whether or not we use broadly pervasive protocols like BGP, or multi-protocol BGP with the extensible network uh, extensions to that allow us to use things like flow specification filters, or maybe we use slightly more structured languages which we can communicate in an encrypted basis over, things such as netconf. And it varies vendor to vendor, but the full suite's available to get the best out of the hardware that's being run currently.
Okay. And can you get a little bit into two, because I understand the standards based, what we're doing, BGP, FlowSpec, so on. What about when it comes to, because I know too, we're doing something a little different with Juniper. So could you talk about that a little bit?
That's right. That's right. Well, so what we're doing there is that the silicon contained within the forwarding plane of the routers specifically has this unique capability to be able to inspect within the payload of the frames that it's forwarding on its main plane. So that gives us an opportunity to be able to perform not just functions desirable for DDoS, such as police, discard, accept, redirect, all those different traffic engineering functions, but it also gives us the detail that we need to be, one, accurate. And if you can be accurate, then the second main priority is that you can automate that. And so having a chipset that is run in the line cards on those devices is highly preferential compared to, say, a chipset that you'd get from a white box generic vendor, because of the capability of the silicon within that compute hardware.
Sure. Okay. Cool. Fair enough. All right, so let's talk about scrubbing a little bit too. First of all, you and I were having a conversation. You're kind of talking about this 80/20 rule in terms of determining
Yes.
capacity for scrubbing. So I guess first of all, just in case, number one, quick definition of what scrubbing is, should anyone not be clear. And then number two, could you get into that 80/20 rule for capacity planning?
Sure. So let's get into it. Scrubbing, the essentially the de facto way or term that's given to the decoupling of both traffic engineering and then the cleaning or the filtering of that traffic for the purpose of DDoS defense on a network. And it's the way it's been done for a long time. It's one of several different architectures depending on priorities that can be used. And essentially it means we take that traffic, we take it out of the path of our transit or peering links, we perform some functions on that traffic, and then we re-inject it on its route to the destination.
Hit the mute. So if I'm an organization, I don't have scrubbing in place, what's the best way to calculate what I need?
Well, I think what we've observed across the networks that we work with is that there tends to be around about 20% of the aggregate edge interface capacity, which has been allocated for the ability to filter out DDoS traffic. And I'm not entirely sure where that figure has come from. I think maybe it's probably to do with the exposure to the internet. But in general, if you had, say, a terabit of exposed interface capacity to the internet, then you would find that in general, approximately 20% of that would be allocated for scrubbing and cleaning,
Mhm.
and you distribute that across the locations in which you deploy.
Okay. And let me ask as a lead in into the next one. So one of the things too is there's not let me get this. If you can have a centralized scrubbing center, you can have regional. There's a lot of different ways it will go. And we'll get into more detail in a little bit. Does that rule still apply, or is it really contingent upon how you architect and where and how many scrubbing centers you have?
I think the rule's becoming less relevant today, and the reason for that is the sort of industry trend and move, and it's not a push from DDoS vendors; it's a push from transit suppliers to move towards these larger 100 and even 400 gig connected capacity interfaces. And so, as the reduction in price per committed data rate comes down, people are moving to these interfaces because those interface prices are coming down on the hardware that they're purchasing too. So it makes complete sense to be able to leverage more capacity and allocate some of that capability for traffic cleaning, if you like.
So now let's get into that where we're talking about placement. So let's say if I'm going the scrubbing route, obviously I've got to figure out where to put these things. So what are the key factors I need to consider where and how many scrubbing centers to place on the network?
That's a really good question. I think for me, the first key factor is undoubtedly what is the provisioned on net capacity between where that traffic is going to enter the network and where the function for DDoS mitigation, or the scrubbing function as we're calling it, is going to take place. And that can also mean the capacity between, certainly if it's decentralized. So if you're running a cleaning location in, say, Asia Pacific, but you have traffic coming in, say, the Middle East or in Europe or in North America, then that on-net capacity to get to your cleaning center is important. If that perhaps, I mean, let's take an extreme example. If that was an undersea cable with a provisioned, bandwidth on a light path, then the cost could be substantially higher than if it was just over, a link within your data center provider across the cross connect. So think about the provision capacity. I think in general, a good vendor will sit down with any network looking at this and will make some recommendations based on what they've seen in the past as well. But it also depends on where your network connects to the internet. So if you're broad and you have these diverse locations to attract traffic for different markets, say North America and APAC as an extreme example, you're going to want to limit the amount of traffic heading across your network to get to that scrubbing center anyway. So I think it sounds obvious, but it's a key consideration. And then I think the other thing to consider is what is on the links where the traffic's going to enter your network, or it's going to enter from one edge to a core or to transit your network. What is the business's risk exposure on those links? And I think if you classify those links into PNI, peering, or transit, arguably a transit link where you're able to leverage more scale on the internet in order to get into your network in the first place, it's probably, I think, reasonably assumed to be a higher risk than, say, a private peering or something like that.
Interesting, because I know you and I have had these different conversations over time, but yeah, that risk perspective, because even though these days, or I have the technical background, I tend to think of like, all right, what's the latency impact if that's there, and
Yes.
that's usually what I think of. But you bring a good point up over, what are your transit costs? What's that cost going to be incurred? But the risk part of it too makes a lot of sense, and that's a key factor to consider, the business risk. So I don't know. So when I look at this, well, I guess we kind of got into this a little bit, but I want to dig a little further. So, I'm looking at trying to understand what the differences are between protecting the network capacity at the edge versus protecting applications from the scrubbing perspective. Can you help clarify that a bit?
Sure. I mean, I think the comparison between the two characterize themselves in the volume of traffic that you're dealing with. And that also is related to the techniques that you employ in order to achieve those different goals. So edge defense is really a strategy that has been born out of the need to provide volumetric defense to be able to mitigate the effects of these large attacks that we know are prevalent on the internet, and do it at a point where the aggregation of transit capacity exists so that we can make sensible decisions about these 100 and multi-100 or multi-10 links in combination with that, make decisions about what we mitigate there. Now, if we do that, then the amount of traffic that is now coming on board into our network or has been taken out of the path is either a different characteristic, so it's a different packet rate, it has different characteristics to it, or it's going to be just in general, it's going to be a lower volume. And once you've got that lower volume, the opportunity to perform different inspection tasks on it becomes greater, because what you don't want to be doing is using a huge amount of compute to perform detailed tasks on a huge amount of traffic. What you'd rather do is use all your resources performing some basic functions. They can still be quite detailed, but relatively do the heavy lifting where the transit capacity is aggregated and exists, and then do the more detailed, computationally expensive tasks where the traffic volumes are lower.
Got it. Okay, thanks.
So, sorry, Mark, just to
Oh,
finish off the
yeah,
question,
yeah. Oh, sorry.
essentially, the protection of the application typically exists post volumetric removal, essentially.
Okay. And there's something, and I'm kind of mixing in something that we had discussed in our at a previous episode,
Okay.
with DDoS protection as a service, and we get into different tiers of service with this. So if I'm offering this as a service, is there a scenario where I'm only providing edge protection as the basic service? Can you unpack that a little bit?
Sure. Yeah. What we see an appetite for amongst the networks we work with are the ability to tier the protection response to either the service that's being sold to the end customer. So this is the customer of the network provider. The ability to tier the response to that, or just to provide a broad classification of defense to a category of customer. So let's say you've got a broadband, a retail broadband customer. A network would typically want one blanket response to those customers. Whereas if you have, somebody serving up software as a service, which performs a large part of their business, you may want to perform many more functions as they, commercially perform, pay for a better service in the cleaning of that traffic. And so having these different service tiers essentially allows you to do that. Edge defense is really digestible because it's extremely clear. It's about protecting the capacity of the link. So the end user understands it, the people that are selling it to the end user understand it, and it's clear it has a single goal. It's what we call a very easy to digest minimum viable product for DDoS defense.
That makes a ton of sense. Okay. So let me ask you this. So it comes into the flexibility part, because we've talked a little bit about where I want to put the protection, where I want to put my scrubbing centers and so on. How many number of factors, right? Most networks are not static as much as we'd like them to be.
Yeah.
Companies change for any number of a number of reasons. So, and I'm going to make this a Corero specific question. Can you talk about the flexibility that a customer may have in that, you design for today and ideally a little bit for tomorrow, but things change. So how locked in are these architectures?
They don't have to be locked in at all. And I think the difference between being locked into an architecture is probably 5 to 10 years old now. And the reason for that is because traditionally, the answer to a DDoS question was, here's a piece of tin. You can send to it what you like, and what comes out the other side is best effort. What we have today is not just is not just various numbers of chassis from various vendors as well to perform a similar task, but a software approach to the problem. And it's software that runs in chassis. It's software that runs on virtual platforms, both open source and proprietary. But it's software that orchestrates the whole story to deliver mitigation and protection to the end customer, because we realize that there are, like we started the discussion with, we've got things we can do on interfaces, things we can do in different routing platforms, things we can do in completely custom silicon for the best outcome for the service that that customer's paying for. So to tie that all together, having one platform to do it on is going to be the ideal approach, really.
Yeah, makes sense. And I think too, so you were talking about, what a piece of tin or chunk of tin, right? So,
Yeah,
but
yeah.
from a perspective, again, from a Corero customer perspective, what differences may I see if I'm deploying a hardware appliance, or maybe when is the time? Maybe I should ask the question that way. When do I want to deploy hardware versus software?
Sure. It's probably about what the capacities you're dealing with on your network are. So if you're dealing with capacities that are say sub few hundred gigabits per second, then those capacities can be achieved cost effectively today in hardware and in software on virtual platforms as well. So think about that. Maybe make some considerations around availability and how you're going to be resilient with those interfaces, especially if you're in the network path of that traffic. Yeah, so that's a key consideration for me.
So if I may, there's a question that was asked too, because I did touch on latency. And so one of the things that we're being asked here is, what was I going to say? So when I'm designing this infrastructure, how much does latency become an issue? And then I'm going to ask this in two parts because these two came in. So you get a twofer. So, all right, how much does latency factor in, or how much is added? And then number two, when I'm looking at the capacity, because I mean, when you look at these, high traffic connections, how are we dealing that? Like, how do you scale up the protection to deal with edge protection? So latency, number one,
Okay.
and then how we're looking at traffic, especially in high volume traffic points.
Okay. Well, latency's obviously a factor if you're going to decentralize your scrubbing, if you like. If it's going to be a long way from the point of traffic arrival or traffic inspection or initial detection, basically, then that is the latency is as long as a piece of string, right? So as long as your fiber is to get to it, that's the latency you're routing, and potentially the reverse pass as well, as if you're not onboarding that closer to the customer route. So that is one consideration. There are architectures to get around that, and people often show a preference for actually deploying those. Excuse me. If you're using edge defense, latency is not a consideration at all, because the performance of the forwarding plane on the switching and the routing that's performing the function is in the path of the traffic. So if you trust the performance of your router or your router, then you've got no problem at all. And it's measurable, it's quantifiable, and it's visible in traffic visualization platforms. Could you just remind me what the second part of the question was?
Yeah, it's like scaling up protection, right? So again, if you've got, if you deploy us, so we're looking at the edge. I mean, some of these are really high volume pipes that are coming in there, right? So how do we particularly scale to meet that? Because am I looking at multiple appliances? Am I looking at how do I approach that?
I think if you're offering your customers mitigation of the DDoS problem, then you're going to be looking at edge defense, because it's where you can get the most level of scale. If you're looking to protect the service, the availability of that application that your customer is serving up, then you're going to want to add either a virtualized instance of the software or a chassis-based instance of that software, so that you can use a custom silicon, a custom chip to perform additional functions on that traffic. Yeah, I think that's the answer.
Okay. Yeah, I was curious because if I'm not mistaken too, we're also not looking at all the traffic, right? Like, so it's a sampling of that traffic. Is that correct?
Well, the trade off on with this problem has always been, if you want to be able to get scale, you've got to sample the traffic. You've got to take little bits of that traffic, because to consume it at volume within and being cost effective about that they're almost two opposing points of view. So to sample is to get enough scale to be able to get a flavor for that traffic. Now that's an area of the industry and a subject we could spend a lot more time on as well, because sampling has been a bugbear for a lot of implementations for a long time, because it's often quite slow to export to get visibility into the traffic, which really leaves you hanging whilst the incident's going on before you can even decide to do something about it. And if it's not automated, then your problem just compounds itself. So there have been a ton of advancements in detection in recent times, which reduce it to a matter of milliseconds, if not just a few seconds.
Okay, great. Parting thought. So if you're talking to a customer says, "Yep, I'm going to go this detect redirect route. So I want scrubbing the whole 9 yards." What mistakes have you seen occur, or what would you advise a network engineer customer to have in mind before they undertake this kind of project?
I'm not sure I've seen a huge amount of mistakes. I think making the most of your edge bandwidth is important. I think sticking with 10 gig interfaces when there are tantalizing deals with transit providers on uh, for a slight uplift in committed data rate, having a smaller price associated with it, statistically enables you to deal with an enormous amount more of events than you would do if you stuck with those 10 gig links. So it's not capacity for capacity's sake, but if you are approaching this problem with a statistical head on, you're going to be able to deal with 80% of all the incidents with just a small uplift in your of what that fiber can deliver in the first place. So have a careful think about that. That's one that stands out to me, I think.
Perfect. Well, sir, thank you. It's
Thanks, Mark.
always
Good to talk.
it's always a pleasure. I appreciate the feedback. We ran some polls. We'll take a look at that data afterwards and share with it. But yeah, as always, thanks for everybody who's attended or even watched this on replay. And then again, Pete, thank you very much. And we'll all see
Thank
you
you.
soon.
Thanks, everyone.
All right. Thanks.
Take care. Bye
Bye.
bye.